Hello everyone, welcome to this channel again. Today it is a problem regarding geometric progression. So we have the fifth term of a geometric progression is 48. The common ratio is 2. They are asking us to find the eighth term and the sum of the first 8 terms. Seems easier, but when terms become higher, it is very good to go through the process here. So in a geometric progression, the first term is called A1, and R is the common ratio. As you can see, if we have the terms, the first term will be A1, the second term will be A1 times the common ratio, and the third term will be A1 times the common ratio, and so on. So each term is equal to the previous term times the common ratio. So if you see these terms, this is how they are presented. So we can say A1 is equal to A1, A2 is equal to A1 times R, A3 is equal to A1 times R squared, and we continue until we get to AN, with n's term is equal to A1 times R to the power of n minus 1. Okay? When it comes to the sum, we can say the sum is equal to Sn is equal to A1 plus A2 plus A3 plus A4 plus A5 plus so on and plus An. So we can plug in, say, A1 times R, A1 plus A1 times R plus A1 times R squared plus A1 times R to the power of n minus 1. So if we multiply the full equation by R, the common ratio, we get R times Sn is equal to A1 times R plus A1 times R squared plus A1 times R cubed plus until we to get A1 times Rn. Now we have two equations here. If we subtract these two, we get something very interesting. So on the first side, we will say Sn minus R times Sn. Very good. So far so good. And on the second side, we see that there are two specific terms that won't be repeating. So it will be A1 and A1 times R to the power of n. The rest are going to cancel each other. So we stay with A1 minus A1 times R to the power of n. So we can factor this, and we can get Sn factoring 1 minus R is equal to A1 times 1 minus R to the power of n. That means the sum of the first n terms. We just discovered the formula. Sn is equal to A1 times 1 minus R to the power of n over 1 minus R. So we combine that with what we found earlier, that An was equal to A1 times R to the power of n minus 1. In our situation here, they gave us A5 is equal to 48, the fifth term, and the common ratio R is equal to 2, and we are going to find the other terms. So A1, an is equal to A1 times r to the power n minus 1 means that 48 is equal to A1 times r to the power of 2 to the power of 5 minus 1. So 48 is equal to A1 times 2 to the power of 4, but we know that 2 to the power of 4 is 2 times 2 times 2 times 2 is equal to 16. So that means 16A1 is equal to 48. We divide both sides by 16. We get A1 is equal to 3. So the first term is equal to 3 of this progression. We can find all the terms from now. So we go for the next terms. So they're asking us to find the 8th term. So we have A1 is equal to 3, R is equal to 2. We can plug in the formula. You know, okay, A8, you know that A8 is equal to A1 times R to the power of 7, 8 minus 1. So we get it is equal to 3 times 2 to the power of 7 is equal to 3 times 128. That should give us 384. Okay, so that is the 8th term. So that answered that question. Now the sum of the first 8 terms, we plug in the formula. S8 is equal to A1 times 1 minus r to the power of 8 all over 1 minus r will give us 3 times 1 minus 2 to the power of 8 all over 1 minus 2. So that means S8 is equal to 3 times 1 minus 256 over 1 minus 2. So we do the calculation. It is equal to minus 3 times 255. So 1 minus 255, 6 is minus 255 times 3 over minus 1. That means makes it 765, and that is the answer. So the first 8 terms will sum up to 765. You can verify. Thank you for watching.